Assalamualaikum and greetings from Malaysia. We are proud to present our e-content innovation titled VISIBIM. See it. Learn it. Coordinate with confidence. Developed by the Studies of Construction, Faculty of Built Environment, FB, University Technology Mara, UITM, Shah Alam. This e-content is interactive, modular, and aligned with industry practices, making it not only relevant but impactful for future-ready graduates. Thank you for the opportunity to showcase VISIBIM at the International E-Content Development Competition 2025, EconDev 2025. I'm technologist Dr. Juliana Brahim, the team leader for this project from the Studies of Construction, Faculty of Built Environment, University Technology Mara. My research background focuses on building information modeling BIM, and I've been actively involved in both conducting research and teaching BIM across various programs within the faculty. Now, let me introduce the rest of the team, each of whom brings their own unique strengths to this project. First, we have Associate Professor Engineer Technologist Dr. Rameza Mohammed Nordin. She has a wealth of experience in construction engineering and project management. Her dual academic and professional background gives her a strong presence in both research and industry engagement, and she plays a critical role in shaping the strategic direction of our work. Next is Surveyor Technologist Mohammed Zaihafiz Zainal Abidin, whose expertise lies in construction project management. He's highly experienced in coordinating construction processes, stakeholder engagement, and ensuring that project execution aligns with overall objectives. His practical perspective grounds much of our work in real-world application. We also have Nurul Hazana Mohammed Taat, who is focused on construction education and technology. She plays an important role in strengthening our teaching and learning frameworks, especially in bridging technical content with effective delivery for students and training participants. And finally, Shahira Mat Sahizal Rajuan, who brings strong skills in digital tools and data analysis. She supports the team by helping us explore and apply innovative technologies, including digital construction platforms and smart data applications. By learning this skill now through VISIBIM, students will gain several important advantages. First, they'll learn how to read and interact with complex 3D models. This means they'll be able to understand how buildings and structures come together digitally, a key foundation in today's construction industry. Next, they'll develop the ability to identify clashes or problems in the model before they happen on site. That kind of foresight saves time, money, and avoids rework. They'll also gain experience working as part of a multidisciplinary team, just like how real projects are done, where architects, engineers, and contractors all collaborate using the same BIM model. And most importantly, this training builds confidence. Students will be better prepared for BIM-related roles such as BIM coordinator roles that are becoming increasingly common and critical in modern construction. In short, VISIBIM helps students stand out. It's not just a technical skill, it's a real advantage when applying for jobs in the construction field. Allow me to introduce you to VISIBIM, a learning philosophy that captures the essence of effective BIM coordination in 3 simple, yet powerful phrases. See it. Learn it. Coordinate with confidence. Let's break that down. See it. This is where it all begins. You start by visually exploring the BIM model. This phase is all about observation, understanding how a project is represented digitally, identifying components, and appreciating the spatial relationships. It's your first step in familiarizing yourself with the digital environment of a construction project. Learn it. Once you've seen the model, the next step is to build your skills. This is where training and hands-on practice come in. You'll gain a solid foundation in BIM principles, tools, and workflows. Whether it's clash detection, model navigation, or understanding data-rich elements, this is where knowledge takes shape. Coordinate with confidence, and finally, after you've seen and learned, you're ready to work collaboratively. This stage is about applying what you've learned in real projects. It's about coordinating effectively with various disciplines, contributing to a shared model, and making informed decisions that drive project success. So, with VISIBIM, you don't just learn BIM, you experience it, master it, and apply it with confidence. Let's begin with the basics. What is BIM? Building Information Modeling, or BIM, is not just a 3D design tool. It's a process and methodology that promotes collaboration among different professionals in the construction industry, including architects, engineers, and MEP teams. All these disciplines work together in a shared digital environment, using the same building model enriched with data. Because BIM brings together various stakeholders into one common platform, teamwork is essential. But even with collaboration, clashes can still occur. For example, a duct may intersect a structural beam, or a pipe might be placed too close to a wall, issues that can cause costly delays and rework if not identified early. This is where the concept of visual checking becomes critical. Visual checking means reviewing the combined model in a 3D environment to identify clashes and coordination issues, understand spatial relationships, and ensure all elements are constructible and properly integrated. This process supports better coordination across disciplines, fewer errors during construction, and stronger collaboration, which is the essence of a successful BIM project. So, why is this important for students? Because the industry today demands graduates who are not only familiar with BIM concepts, but who can think and work in a collaborative, model-based environment. Understanding how to navigate and interpret a federated model, detect issues early, and communicate effectively with a multidisciplinary team, these are real-world skills that make you industry-ready. In short, learning BIM as a process, and especially the practice of visual checking, gives students a strong foundation to take on roles in modern construction projects with confidence and competence. Now, let's look at the 3 main steps involved in visual checking within a BIM workflow. Step 1. Importing and setting up discipline models. Step 2. Visual checking with sectioning tools. Step 3. Mark and save key issues. These 3 steps form the backbone of visual checking in BIM, helping us identify issues early, improve collaboration, and reduce costly on-site errors. Next, we'll begin the hands-on tutorial. In this session, you'll get the opportunity to practice visual checking yourself. We'll guide you step by step, from importing the models, navigating and inspecting the 3D environment, to marking and saving identified issues. This is a valuable skill to prepare you for real-world BIM project collaboration. Select the file you wish to append into Navisworks. Please make sure you have selected the correct file. For this video, we will be selecting the NWC file. Once all discipline files have been added, rename and save the working model in the Navisworks file format, or NWF. Please note that in the NWD format, further changes cannot be made as it is in read-only mode. This format is used to review and coordinate models together within a single file. With the combined models open in Navisworks, visual checking can begin using the sectioning tools. These tools allow you to cut through parts of the model to inspect internal elements that are not visible from the exterior view. This is helpful when identifying clashes or checking detailed areas. To begin, go to the Viewpoint tab, click Enable Sectioning. Click the bulb icon next to Plane 1. Then, choose your preferred alignment and adjust the view as required. Use the blue arrow to move the section plane and examine different parts of the model. Alignment allows you to view the model from above by dragging the arrow downward. The Align to View option adjusts the plane to your current perspective. Meanwhile, Align to Surface matches the section plane to a specific surface within the model. These functions allow flexible viewing angles and help users inspect coordination issues from various directions. Next, saving the view allows you to refer back to it later or share it with the team. Click Save Viewpoint under the sectioning tools. The saved views will appear in the Saved Viewpoints tab. Rename them clearly. Repeat the same steps for other viewpoints. Finally, organize them into folders if needed for easier access. Saving viewpoints is useful during coordination meetings. It allows teams to focus on specific issues and helps streamline the discussion process. By documenting key views, the team can track problems more effectively and ensure resolution before construction begins. This output represents a VISIBIM visual model created using design tools and reviewed in a VISIBIM Viewer. It integrates architectural, structural, and MEP components in one environment, allowing users to assess spatial planning, design clarity, and buildability. While no clashes are found, the model improves understanding of system interactions. Through this task, students explore the basics of creating and interpreting VISIBIM visual models. They learn to navigate, isolate elements, and evaluate design logic. This experience builds essential digital skills for modern construction, preparing learners for data-driven environments where visual clarity and model-based communication are key industry expectations. Let's wrap up with a quick summary of what this module is really about and, more importantly, why it matters. This module introduces students to the fundamental concept of building information modeling, BIM, as a collaborative process, not just a software. It emphasizes the importance of digital coordination in the construction industry, where models from multiple disciplines are integrated in a shared environment. One key task is visual checking, a practical method used to identify design clashes, misalignments, and other coordination issues early in the project lifecycle. By detecting these errors before construction begins, teams can avoid costly rework and ensure smoother project delivery. Through hands-on tutorials, students gain real-world experience in navigating 3D models, performing visual checks, and managing coordination using BIM tools. These activities simulate actual industry practices, preparing students for roles such as BIM coordinator or project engineer in BIM-based environments. The skills developed in this module, technical, analytical, and communication, are highly valued and will give students a competitive edge as the construction sector continues to embrace digital transformation.